Alrighty, so here is our review. We're going to graph each of the following parent functions and pay attention to the fact that it does tell us to do it on a specific interval. So since these are all the parent functions, my scale on my x-axis can be what we have been using. So I'm going to label this on here, make this pi halves, this pi, 3 pi halves, and 2 pi. And we're supposed to go from negative pi to 2 pi. So there's my 2 pi. So this is negative pi halves and then negative pi. So I don't have to fill in the whole grid, but I do need to go from negative pi to 2 pi. So as I go in here and I graph my parent function, I also need a scale on my y-axis. Now I could use this first one as 1, but I'm going to use this one as 1, and this is negative 1, just so it's not quite as squished. All right, so you should have an idea of what the shape looks like for a sine function, but you can also think around your unit circle. So when x is 0, the sine of 0 is 0. You go to pi halves, the sine of pi halves is 1. The sine of pi is 0. The sine of 3 pi halves is negative 1. The sine of 2 pi is 0. Okay, so that's where we get that from. So there's my 1 cycle, and that's why my normal period for sine is 0 to 2 pi. But I have to go to negative pi. So you can think along the graph to think about what the actual values are, but this is a periodic function and it repeats. So if we've come up, we're going to come back down. We're here, then we come back up to 0, and there is sine of x from negative pi to 2 pi. So now we're going to go to cosine. Same thing, I'm going to do pi halves, pi, 3 pi halves, 2 pi, and then negative pi halves and negative pi. All right, so for cosine, I also need my y scale. Make that 1 and this negative 1. I might want to change that if I had an amplitude here that was something other than 1, but since it's 1, I'll just leave it like that. All right, so when x is 0, at 0, the cosine of 0 is 1. The cosine of pi halves is 0. The cosine of pi is negative 1. Cosine of 3 pi halves is 0. Cosine of 2 pi is 1. So here is my parent function in 1 cycle in my normal period from 0 to 2 pi. But I need to go out here to negative pi, so this comes back down to 0. And then here we're at negative 1. There you go. My graphs look a whole lot better when I'm not actually writing on the tablet itself. All right, so then tangent. I'm going to use the same scale. So this is pi halves, pi, 3 pi halves, 2 pi, negative pi halves, negative pi, make this 1 and this negative 1. All right, so tangent. At 0, when x is 0, tangent is 0, because tangent is sine over cosine, and my sine is 0, so it's 0 over 1, and we're here at 0. At pi halves, the tangent of pi halves is undefined because that would give me 1 over 0. So this is where my asymptote goes, which means something's happening in here. So at pi fourths, I know at pi fourths, the tangent of pi fourths is 1. So there's my point right there. So then at pi, the tangent of pi is 0. And again, something is happening in here, right? And this one was going to be at negative 1. Then here, this is my other asymptote. So at 3 pi halves, tangent is undefined. And in here, you would get 1. Okay, so my normal period for a tangent is pi. So that's 1 period. And then I don't need to draw in this asymptote because I'm only supposed to go to 2 pi. Well, at 2 pi, I'm back at 0. And then halfway in between here, I'm at negative 1. So this full one looks like this, which means here, just from 2 pi, it's going to look like this. So then go pi over, so this is pi halves, another pi halves. Here's my other asymptote. And here, this is at -1. So I get this repeat because it's a periodic function. And then I have to go to just to negative pi, so I'm not even going to draw in my other asymptote. But at negative pi, I'm back at 0. And here, this is at 1. So it looks like this. And that's what the graph would look like from negative pi to 2 pi. All right, so now we're going to find the indicated attributes for the given trig equations. All right. So here's my equation. My amplitude is 1. Remember, you don't say none for a cosine. It does have 1, and it's 1. Your normal period for cosine is 2 pi. My b is 1, so my period is 2 pi. Horizontal compression or horizontal stretch, well, since b is 1, then I don't have 1. You could say none, you could say 1, you could put NA, you could put a dash. All those are fine there. It doesn't really matter. And then your phase shift, you would factor out if you needed to here. We don't need to. So my phase shift, I know moving to the right since that's negative, and it is pi fourths. And then my vertical shift is +1, or +1. And in general here, I have y equals a times the trig, whatever it is, sine, cosine, or tangent, of b times x minus c plus d. Okay, so there's your a, b, and c in there. All right, so my amplitude here, my a is 2. My period, so my normal period for sine is 2 pi, or since this is in theta, it is 360. And remember, x lies, so your b is 1/3. In order to find your period, you use the normal period, which would be 360 here. You divide it by b, so I'm dividing it by 1/3. So basically that gives me 3 times 360, which is 1080. Horizontal stretch or compression, well, there is one because b is equal to 1/3. And since b equals 1/3, x, you do the opposite. So instead of multiplying by 1/3, you divide by 1/3, which is the same as multiplying by 3. Your phase shift, there isn't a c, so there is none, so it's 0 or none. Then your vertical shift is a -2. All right, number 7, your amplitude is 0.5. And the period here, I take my normal period for sine, which is 2 pi. We're in radians because it's x, and I divide it by 3, so this is 2 pi thirds. And then my horizontal stretch or compression, b is equal to 3, so this would be 1/3 here. There is no phase shift, and my vertical shift is 0 as well. My amplitude is always positive, so that negative tells me I have a reflection in the x-axis, but it doesn't affect my amplitude. My amplitude is 1. The only time you're going to say none is if it's tangent. Tangent does not have an amplitude, however, the a is still important to us. All right, so then the period, this is theta, so that means I'm using degrees, so my normal period is 360. There is no b, so it's 360 degrees. My horizontal compression or stretch, there isn't one because there's no b, so it's none or 1 or not applicable, but not 0, obviously. Then my phase shift or my horizontal shift, this is positive, so that's going to give me a -180. There was nothing to factor out there. And then my vertical shift is -3. All right, so then number 9, my amplitude, a is 2/3. Then I need my period. My normal period for sine is 2 pi divided by 2 gives me pi. My horizontal stretch or compression, there is one. b is equal to 2, which means I'm going to divide by 2 or multiply by 1/2. And then my phase shift here, I need to factor out. So this becomes y equals 2/3 times the sine of 2 times x minus pi 12ths. You can always double check yourself when you multiply back in. 2 times x is 2x. 2 times pi 12ths would be 2 pi 12ths, which is pi 6ths. So things look good there. So your shift, this is negative, which means it's a positive shift of pi 12ths. And then your vertical shift is 0, because there isn't one. All right. So now we're going to graph each one of these, again on our domain of negative pi to 2 pi. The only reason I might want to change my scale on my x-axis is if I have a compression or a stretch that would just make it too difficult to do it on the one that I've been doing, but I think we're good on that, so we'll leave it as pi halves, pi, 3 pi halves, and 2 pi, and then negative pi halves and negative pi. Now, the only reason I might want to change my scale on my y-axis is if I'm stretching or shifting so much that it would just go off the grid. But I think I'm good leaving this at 1 and this at negative 1. So you can go about this a couple of different ways. What makes the most sense to me? I mean, you can make a table and just go ahead and substitute in these key points. That works, but sometimes if you're just substituting in the same things over and over again, it's not really going to line out to give you the points that you actually need. But what I would have on my parent function for cosine is I would be here at 0, 1. Okay? So let's think about what happens with your x value. Well, your x value is being shifted, and this is subtraction since you see a positive pi. So we're going to shift to the left pi. So instead of here, I'm going to be way over here at pi. And then my x value, my y value, it's shifting up 1. So instead of at 1, we are going to be at 2. So then if I'm here at pi halves, I would have been at 0. Okay? So I'm still going to shift to the left pi and then shift up 1. Here at pi, okay, so now if you kind of understand what's happening, you were here at 0, and so then you're going to be coming back down, because at pi you would have been at negative 1. You shift over to the left pi, and then you shift up 1, and you're here. And really you don't need to do much more to understand what's happening with the graph. This is a cosine function. You should know what the shape looks like. So it's coming down like this, which means this is where your axis was. So next you're going to hit here, and then here, and then here, and here. And it'll look like that. Okay. Alrighty, so now I have y equals negative sine of 2x. Alright, so there is a compression here, right? It is a horizontal compression, but I think I'm going to go ahead and leave my scale the way it was, because it's not that big of a deal to compress this, and plus then if you always change your scale, then your graphs might always actually look the same, just with a different scale, and I want to make sure you have an understanding of what they're supposed to look like. If I was going to do anything more than a 2 there, I would probably change my scale, maybe, depending on what it was, but we're going to go ahead and leave this as pi halves, pi, 3 pi halves, and 2 pi, negative pi halves, and negative pi. And there is not a vertical stretch or shift, so I can just leave this again at 1 and negative 1. Alright, so sine. For my parent function, I would start here at 0, 0. Okay? So my x is being affected. This is 2 times x, which means instead of multiplying by 2, I divide by 2. Well, 0 divided by 2 is 0. And then I'm going to reflect it in the x-axis, which means it's still right here, and that point is very uneventful. At pi halves for the parent function, I would be here at 1. Right? So I look at my x value. So my x value is being divided by 2. So that means I'd be here at pi fourths for my x value. And then it's being reflected in the x-axis, which means my point actually comes down here. Then at pi, because I already did 0, I did pi halves. Now pi for my parent function, I would be back here at 0. So I'm going to take pi and I'm going to divide it by 2, so that gives me pi halves. Then I reflect it in the x-axis, very uneventful, we're still right there. Okay. So then I have 3 pi halves. So when you do your parent function, come here, and then at 3 pi halves, I was here at -1. So I'm going to take my 3 pi halves, I'm going to divide it by 2, which is 3 pi fourths, which brings me to right here. Then I'm going to reflect it in the x-axis, which brings me here. Then I'm going to do 2 pi. I take that x value, it gets divided in half and gives me pi. And then I reflect it in the x-axis, and we get that. So here is one cycle of my new function. And because it's a periodic function, you can continue your picture pretty easily with the pattern. And if you're going to go, do it like halfway in between, then I sort of missed mine right there, but my point's there. That's good enough. Just make sure you're not being crazy about where it goes. So again, it's periodic, so it's going to come down here, then it's going to come back up, and it's in between here, comes back down, and you should be able to finish off your graph. You have to actually plot points. Like I need to see points there and not just some shape that you did. Alrighty. So here, let's look at what's happening. This does have a horizontal stretch in it. It's just by 2, and it does have an amplitude of something other than 1. So I can change my scale if I want to, but I think I'm going to go ahead and leave it here as well. And so in the end, if you changed yours might look different than mine when you're done. It's fine. I'm not saying it has to be this way, but you should be able to tell that your key points are where they need to be. And that's another reason why you have to actually label what your scale is. And I think since my amplitude is just 2 and there's not also a vertical shift, I'm still going to leave this at 1 and -1. All right, so for sine, my parent function would look like this. So I have in my mind, I know I would start at 0, 0 with my parent function. The x value gets divided by 0.5, which is the same as multiplying by 2. So 0 times 2 is 0. And then my y value gets multiplied by 2 because of the amplitude, which still leaves it at 0, 0. Very uneventful when you're dealing with 0. Okay, so then again, for my parent function, looks like this, right? So at pi halves, I'd be here at 1. So instead of pi halves, my x value gets multiplied by 2, so it becomes pi. And then the y value gets multiplied by 2, so instead of 1, I'm here at 2. So then at pi, because I went here, and then pi, we're back here at 0. So my x value gets doubled, so instead of pi, I'm at 2 pi. My y value gets multiplied by 2, but that leaves me here at 0. Okay, so I only have to go to 2 pi, so I'm good there. So now maybe I need to go and figure out what's happening the opposite way. If this was my parent function, it would look like this, right? So I'm going to come down here, and at negative pi halves, I'd be at -1. So negative pi halves, I'm going to double my x value. So negative pi halves times 2 brings me to negative pi. And then my y value gets multiplied by 2. So instead of -1, I'm here at -2. And so it has spread out my function to look like that. And that's what I get from negative pi to 2 pi. All right. And then I've got cosine. Now here, my x value is going to be divided by 3. So you could change your x scale to where it's pi thirds, because maybe that would be a little bit easier for you, but it's really not bad to leave it. So I'm going to leave it just so you can understand how to think through this. Okay, so this is pi halves, and again, yours could be different. You just have to make sure that your key points are at least plotted, and which means your final draft might look different than mine, but it doesn't mean that we're wrong. It just means that our scales are different. And then as far as my y-axis goes, I do have a vertical shift, but it's only of 1. So I think I can still leave this here at 1 and at -1. Okay, so for my parent function of cosine, I am at 0, 1. My x value is going to be divided by 3, so 0 divided by 3 is 0. And then my y value gets shifted up 1, so instead of at 1, I'm up here at 2. All right, so pi halves for cosine, that would be here at 0, so it would be pi halves 0. My x value gets divided by 3. All right, so pi halves divided by 3 is pi sixths. And if you think in terms of degrees, this is 90, and so that would give me 30. So I do have like a 30, 60, well, 60, 90, right? So this is pi sixths, pi thirds, pi halves, 30, 60, 90. So just so you have an idea, you can basically, I've just broken that up into thirds just as I would around on my unit circle. So I'm here at pi halves. Pi halves gets divided by 3, which ends me up here at pi sixths, and then I get shifted up 1, so I'm here about a third of the way over. Okay. Then I'm at pi, right? And so for cosine, I'd come down like this, and then at pi, I'm at -1. So pi, I'm at -1. My x value gets divided by 3, which gives me pi thirds. Pi thirds is right here. Remember, this is 0, pi sixths, pi thirds, pi halves. So I'm here. I come over here to pi thirds, and then I get shifted up 1, which gives me right here at this point. Okay. Then at 3 pi halves, right, so for cosine, I was here, come down here. At 3 pi halves, I'm back at 0. So this gets divided by 3. Well, 3 pi halves divided by 3 is pi halves. And then I get shifted up 1, which is going to put me right here. So notice how this little section here just got broken into thirds. And then at 2 pi, so for cosine, I'd come down here, back up, and at 2 pi, I'm at 1. So 2 pi, I divide that by 3, and I get 2 pi thirds. Okay, so if this is pi thirds, then I've gone 30, 60, 90, and then 120. So right here is your 2 pi thirds. It's about a third of the way over, right? And then that would be more. So there's your, again, 90, and then 120, 150, 180. So at 2 pi, I'm here at 1. I divide that by 3, and I get 2 pi thirds, which brings me to right here. And then I add 1 to my y value, and I'm here. Okay, oh, a little too far, so I'll do like a third. And then it looks something like this. Now I've got to continue on. I've gone a third of the way. When I come back down here, I'm the next third, and then the next third. And I go back up, I'm a third, and then 2 thirds. And come back down, I'll be on the axis. Then I'm at a third, back up here at 2 thirds, now I'm back on the axis. So it'll look like this. You could make a whole table of values if you want, but at the very least, you have to have points plotted, not just some random shape there. So I move over a third, I'm here, come back down another third, and I'm here. Then I'm back up here, here, and here. Here's what my graph would look like. Shoot, that was doing pretty well. Okay, And there you go. Labeling is huge. So if your scale is different than mine, it's fine, but I want to see the labels. All right, so then it says the given parent graph point would become what point under the transformation indicated in the equation. So this is different than the ones we looked at in math time where it was, does this point exist on the graph, which is something else we need to look at. This is saying this is the point I start with, kind of like what we were doing on the graph. And then what is it going to look like under this transformation? So, okay, so I first look at what is happening to my x value. So with my x value, I have 3 pi halves, and I'm going to subtract pi halves, because I do the opposite. So 3 pi halves minus pi halves give me 2 pi halves, which is just pi. That's the only thing that happens to my x value. Then my y value gets multiplied by 3, so that's a negative 3. Then I look at what's happening to my x value when I use 2 pi. Well, there isn't anything. There's not a b or a c there, so 2 pi remains 2 pi. But for my y value gets multiplied by negative 1 because there's a reflection, and then I add 1, so negative 1 plus 1 is 0. So then I have 2 pi. When I substitute in, or when I use 2 pi in here, this 0.5 is really 1/2. So instead of being multiplied by 1/2, we're being divided by 1/2, which is multiplied by 2. So this 2 pi gets multiplied by 2, which is 4 pi. Then my y value, which is 0, gets multiplied by a negative 3, which is still 0. And then we subtract 1, which is negative 1. My x value, I add pi because you're doing the opposite. Okay, so pi plus pi gives me 2 pi. And then your y value is being multiplied by 2, so this is negative 2. You should be able to do just fine on your test. Make sure that you understand your values as you go around the unit circle as well. That's all tied to this graphing, and it can help you do it different ways. If you don't graph it in the exact same manner I do as far as how you're looking for your points, if you prefer to get a table, that's fine, but you can't spend 5 times as long because you're trying to make an entire table. You need to understand that it's a periodic function that repeats itself. And label, label, label.